Hello, everybody, and welcome to today's Dev Talk. We're so excited. We have Majid Krosta from our Zebra Aurora Vision team, who's going to be sharing some deep learning technology with you, talking about how to create OCR solutions. And so we're going to get that underway in just about a minute here. But I first wanted to go over some housekeeping rules with everybody. And just kind of give them an idea of how this is going to work today. So we'll go ahead and we'll have him present his Dev Talk. And at the end of the Dev Talk, we ask that you pose your questions in the Q&A box up in the queue there, and we'll read the questions towards the end. This Dev Talk is being recorded. We will place this on our YouTube Dev Talk playlist, which we can share with you once it's available. Majid, can you go to the next screen so I can go over some things with everybody here today?
Yes, okay. Let me just start the presentation.
There he is.
Here.
Say hello. Hello.
Hello. Hello. So not this presentation. I'm sorry. I launched the wrong one, but this should be good now. So you wanted another slide, yes? So please let me share the screen now, and it should be good.
Okay.
So do you wanted to say something about the developer Zebra, or do you want me to?
Yeah,
start?
if you could just share the beginning of the presentation, then we can get underway and I can show everybody our developer portal.
Okay, so you can see my screen right now.
No, we cannot.
That's weird because I did click on the share button. People can see you.
Sorry to interrupt. We could see your screen. Yeah, we can see that now.
We can. Okay, great.
Okay.
All right.
That's great.
Thank you, James. James Swinton-Bland is here joining us as well. All right, so we just want to go over a couple of things today, and this is our developer portal. If you haven't visited our developer portal, we invite you to visit it today. It's free to obviously access, free to join, and there's a plethora of information for you on that developer portal and forums to ask any type of questions that you may have. So there may be questions that come up after this webinar. You can post them in our forum there according to our blog that we have for today's presentation. You are also invited to, of course, email us at any time. Our email box is developer@zebra.com, and we monitor that all the time. So if you have questions that come up, please do not hesitate to ask us. Next slide, please.
Okay.
And I just wanted to prep everybody for our upcoming Dev Talks over the next 2 months. We're really excited. We're going to have the Visibility IQ team back in on a Dev Talk to talk about the new APIs for application health and battery health. So those are some new releases that are coming out, and Manuel and some of the team will be sharing that with our audience on Wednesday, July 20th at 10 a.m. Central Time. The next cool thing that we have coming up is our Zebra Dev Talk Community Day. We're really excited. It's an all-day RFID. We're going to have about 4 or 5 talks in a row. It's going to be talking about the new IoT connector and a lot of other topics related to RFID. So if you haven't developed with RFID before, or if you're interested in a lot of the updates and the releases, please join us. It's going to be a nice full day, actually half a day, I should say, between the time zones from August 24th through the 25th. And that's available globally. All of these webinars always are and always recorded for you. So with that, I'm going to go ahead and shut down my mic and turn it over to you, Mr. Krosta. You are on.
Okay, so let me introduce myself properly. I am Maciej Krosta, and I am a machine vision application engineer at Zebra Aurora Vision in Poland. So I've been working for a few years here, even before we've been acquired by Zebra. And today I would like to talk about deep learning technology, especially those deep learning technologies that can be used for optical character recognition. And we will be all doing this in our main product, Aurora Vision Studio. And I will show you how to create an application that can read text from photos. So I would like to start with some brief description of what we have at Zebra Aurora Vision. So we basically provide a software solution for creating vision applications, be it in Studio, which is our graphical environment, or you can also program in C++ or .NET on the .NET platform with our library. And one of our most popular products are our various deep learning filters, which can do a plethora of things like classify whether an object is okay or not okay, detect some defects, or, which is the topic of today's presentation, can read characters from the screen. So I would like to emphasize that this is a full solution. We do not need anything else when we are using this environment. We can create the program on basically any camera. We can develop our own algorithms, and we can even create our own interface. And one of the most important things is that we are hardware agnostics, because as mentioned, we've been acquired by Zebra, but before that, we specialize in the fact that we can work with any camera, basically. Right now, we are, of course, will be focusing on the Zebra cameras, but it won't change the fact that you can use our software with, for example, with a third-party camera. So basically, I could read all of that is on this slide, like the fact that we've been on the market for over 15 years. But I think it would be best if I just showed you our environment. So let me exit. So I hope you can see my screen that shows the Aurora Vision Studio Professional. So this is our bread and butter application with which we can design our application, debug them, and whatnot. So right now, our program is, of course, empty. We have to add something. So I have prepared a camera and some stand for this. So let's start with grabbing an image from the camera. So we can use GennyCam filters, because GennyCam are quite universal. GennyCam is a universal protocol for cameras. A lot of cameras can support it. So when I start the program now, we can see that we have a live screen. You can see my hand here. So it won't be surprising that I would like to read something from the screen given the topic of this webinar. So how can we do it? If we want to use our deep learning OCR, we need to find a filter called read characters. And we can just drag this here. We have to connect the frame, the output, into the image, so that our deep learning will read on the camera provided by the camera, on the image provided by the camera. So when I launch it now, it will take some time, but we can see now, when I drag the output here, that we have a lot of characters read on the image already. And this is just adding one filter, and everything is working without any other preparations. Of course, you may notice some slight problems, like the fact that we don't read the parentheses. So how can we fix that? We have here the input called character range. And as we can see here, we don't have any parentheses here. So let's add the parentheses after commas. And now it's just started to read it. So yeah, right now I would like to pause for a second and explain what exactly is this filter DL_read characters. So this is our deep learning filter that is connected to our specialized OCR model, which has been trained on a lot of images, like probably more than thousands of images, but I don't know that many details about it. So we basically trained it on various images from, texts like this, which is quite clearly legible, to dot print, to some other kinds of text, even, those that are not flat on the surface, but go upward or downward. And our model is, thanks to that, prepared to read as many characters as possible, which sometimes, as you can see here, can also lead to some problems. Because if we look closely, we can see something that resembles the letter A. Of course, our model wants to read as much as possible, but we can control it with proper parameters. Okay, so let's see what we can also add to what we can also do right now. Because we don't really want, normally, we don't want to read everything that is on the screen, because most of the information are not really important to us. Like we don't really care about remove to expose adhesive, because that's something that's on every product and it really is not useful for us. What we want to know, for example, is the address of the sender and the receiver, right? So how can we control this? This is quite easy. We have this input in ROI, which stands for region of interest. And we can just draw a rectangle here. When now we need to compute it again and show it. And now we can see that the characters that we have now are limited to this rectangle. So when I go live with the image, we can see that if I obscure it, nothing is here. Okay, but right now, this is nice, but we just have some characters in some arbitrary places. We don't yet have any text. So to fix this, we can use another of our filters. This one is not based on the deep learning. Merge characters into lines. And if we connect the characters into this and run it, let me just add another view here. And we have basically it grouped all the characters into words, and it gave us those words in an array here. So we have Klein, Mr. Harry, and this is first problem, because the order is yet not found. It's not preserved. If we don't care about spaces, for example, we can just increase the gap even larger. And now all the lines of text are just one line, and this order is preserved. And now we can read the address of the sender. However, there is this one problem because our region of interest is set manually. We can see it here. This is this rectangle. So if I were to move this, we will stop reading this because it's no longer where we want it to be read. So this is one of the problems with OCR application, because a lot of times there is a lot of text visible from the camera. We are only interested in some of it, and this text can move relative to the image. So in this case, we have to find a way to position our region of interest so that the text is correctly read. So when we look at the image again, we can try to find some characteristic points that will be easy to find on the image and on which we can position everything that we will do later. So if we look at that, when I move it, one of the things that stands out the most is this logo here, or rather not logo, but a symbol. So we have to locate this, and then we will be able to use it as an anchor. So as I said, our environment provides a lot of tools for vision processing of images. And another of those tools is locate object. So let me just drag it here. We just want to find one object. And let's define what we want to find. So this is a nice pattern to find because it's quite sharp. It's based on the edges. So the stronger the edges, the better it looks. So when I draw around the letters and move it closer to zoom it in, we can see the red lines are what edges are, the edges that are detected. If we smooth it out a bit, we now have very simple edges to find, which are quite unique in this image. So if I now show the match here, we can see that this is detected. If I start moving it, we can see that the green rectangle follows the letters. And this is basically our anchor. Now, when we detect something, this something in this case is called object here. It provides a lot of information. One of those information, one piece of this information is alignment. So basically, what it is a coordinate system. We can see this here. and it moves along along with the green rectangle. So we have alignment. And now we can use this alignment here. We can connect it in to the region of interest alignment. And if we define the region of interest again, but this time using not the absolute coordinate system, but the in-row alignment, I need to run another iteration because it has to have the information. We can position it as closely as we want. We can even rotate it a bit because the envelope is quite a bit rotated. And now, if we put it here on the display, after it finishes computations, because it is all right. So now we can see that the aligned row is here, and it moves along with the green rectangle. And we can see that our OCR reads everything, even when I move the envelope. Of course, when I'm moving, the image is getting blurry, so we need to stop and let it stabilize. So basically, we have successfully read text from the image where its position is not, it changes over time. It's not guaranteed to be in the same place. Some keen-eyed amongst you may have noticed that sometimes we have some additional strings. Let me just display the characters. Yeah, so we can see that, for example, here, from time to time, we detect characters that are not really there. And well, this is one of the necessary drawbacks of this deep learning model, because it is very greedy. It will read as much as it can. If we look in the parameters of that filter, we can see in polarization. Right now, it will try to read dark characters on bright background and bright characters on dark background at the same time. So if we were to set it to only look for dark characters, we should we should have ridden ourselves from those phantom characters. However, if that would not be enough, we can also increase the threshold for contrast, because even if we could see something here, it would be very faint, and its contrast compared to the background would be quite low. So we could use this as a means of filtering. So let's say that we want to read another lines of text. For example, we want to read those, because this text, as you can see, is a bit different from the rest. It's larger and it's also bold. So I'll swap. Okay, we need another iteration. I'll swap the region of interest for the larger text. Of course, we don't need to be as tight fit as possible. We can add more in place. And we can read this as well. However, if we were to take the ruler and measure the text, of course, roughly, because each letter has a different height, we can see that we have 45 pixels of height, about. And also we have some phantom characters from time to time. Now, so the characters as I said, should be possible to remove with a contrast threshold. And I think that 0.2 should be enough. Now it should not show up here. But there is also another parameter I wanted you to look at, and this is character height. So it's set to 35. So by default, right now, our deep learning OCR model tries to find characters or other focuses on the characters that have 35 pixels of height. It will read larger text, as we can see, but this text probably will not have as high score as possible, so it may sometimes just ignore it. So we can just increase this character height to 45. We don't have to be very precise, but 45 should be better. So we can now read those lines of text. And of course, it will follow our logo. Now, of course, there is this thing that we have it as a one line of text. Because merge characters into lines, we wanted to have just the lines of text. We didn't want to have to fix the ordering of the words. Of course, it's not something that cannot be done. We can add some other filters and functionalities to our program so that it can sort the words based on, well, position. But first, I would like to read all this text, both the sender and receiver, at the same time, because I had to change the ROI, the region of interest, because as you can see, it is a rectangle. Of course, we can do this. And in this case, it probably will work because this horizontal line will not be mistaken for a letter because it's too wide. But as I said before, right now we are focusing on 45 pixel characters. And here the H is 26 pixels. So we are compromising on the accuracy of reading here because 26 and 45 are basically, one is basically half of the other. So can we do it another way? Of course, we can, for example, let me stop the program. We can, for example, just add another read characters. I just Ctrl+C, copy and pasted it. Connect it as before, especially the alignment. And right now they are set, one is the copy of another. So both read the same thing. So we can basically have this one focus on the bold text, or basically those three lines because they are larger. Let me actually stop. And the other one can focus on the smaller letters. You can also put it here. And we should add another match characters into lines. Copy, paste, and this connected here and this connected here. So if we run the program now, we have two arrays of strings. And if we now reduce the size here to about 25, yeah, what I wanted to show you, because when it was set to 45, we can see that we have Mr. R, Harry. This one. We don't need the rest. So the OCR is confused by the small letters here, and it decided to add another. It sees another letter R. However, if we were to reduce the expected character height to 25, not only is this R removed, but all the other rectangles, the character boxes, appear to fit the letters a bit more closely. So that's why we wanted to separate those lines and the bottom lines because of the height difference. You can see that it kind of worked for one character height. If we were to set character height of 35, it should be in the middle and everything should be red. But with very little cost, we can increase the accuracy of reading because this is one of the quirks of the deep learning. With the deep learning, you cannot really be sure why something has been detected that way, because the neural nets is quite difficult to understand what is happening inside. Okay, so we have two arrays of strings, and both will follow the logo, of course, as long as the logo is visible, because this is our anchor. So if we can see that this and this, if I obscure the logo, the alignment just disappears. And another thing, which is not as closely related to OCR, but very important for positioning in general, we can see that the ROI, the aligned ROI, jumps a bit from left to right, because the images are, even though nothing is happening right now, each image is different. There is different amount of noise. So what we may want to do is to increase the area of search. Basically, we can add more edges like that. And with this, it is a bit more stable because now it has to fit to more edges. So even if some edges are not visible due to noise or something, there is, well, the more you have, the less noise effects, noise in the image, of course. So about the deep learning again, we have three trained models: extended, balanced, and fast. Actually, let's stop the program now and let's see the statistics. Read characters takes 36 milliseconds and 16 milliseconds. So if we were to go fast, we appear to have the same results as before, but we have shaved off some milliseconds, 31 and 6, so it's about 15 milliseconds total faster. So that's quite important to know that we have 3 pre-trained models at our disposal. And of course, there are some compromises for the fast model. So that's quite, sometimes you just need to test which model will be the best for your use case. Now, the times I'm achieving right now with the fast model and whatnot. Oh, okay. I apologize. I made a mistake. I did not switch to fast before, so it was faster because of the fact that you know before the statistics were also run for moving pictures. That's why it was slower. Now we can see that the fast model has 60 milliseconds and 9, which is considerably faster. Now, those are times that I achieve on my work laptop, which is fitted with a graphics card, with an NVIDIA GPU. Because neural networks are best suited for GPUs due to the fact that they have many cores, and neural networks has basically a lot of simple tasks which are very easily divided amongst the GPU cores, the CUDA cores. However, if we do not have any dedicated graphics card, it's not a problem, because we can also set the type to CPU both times. Now our both read characters will work on the processor. When I run it now, we can see that it is a bit slower. Yeah, it's about 10 times slower, even more so, because the processor does not have as many cores. So with neural networks, it's better to have more processing cores that are a bit slower than to have few cores that can be fast, because it's not easy to parallelize this task so much. And also the fact that everything else in the program, like locate object, is also working on the CPU. So by switching to the GPU or the CUDA here, we don't have to put as much strain on the processor. So that's why the difference in time is so noticeable. Now, you might have noticed that we have the model directory here. This is something that is not yet available for the average customer, but basically we plan to in the future to offer the possibility of training your own model, because this is very universal. It will be dot print. Basically, it will even read those numbers, right? We can just we can just add another one. Let me just multiply this here. We can connect it here with the image, with the alignment, and put the characters here. And after running it once, we can set the region of interest to this. And of course, this is a much larger text. So you can see that the OCR model doesn't really know what to do, because there's too many possibilities. This character has the height of 110. So let's set this here. And also we have a steep contrast threshold. Now it's reading it. So yeah, if I move it and put it here, so you can see this is the same model still. It's the fast model actually. So one model, and it can read this text, it can read this text, this font, and many other. So it's very universal, but with being universal, there comes this drawback that sometimes you don't want a universal solution, but a dedicated one. Because, for example, maybe you are interested in only this font. So if the model was trained on only this and only this font, it could get even faster, and there would be less ambiguity between different fonts, because sometimes you, like this font has the L very similar to the capital I, basically it's the same. So in this case, it's very difficult to discern between them. And other font may have those letters quite distinct. So if you had the other font, you don't want your OCR model to be prepared for the ambiguous I, because that would be just wasted resources. So right now, our customers, clients cannot train their own models, but we can offer them that we can train the model for them. But of course, it requires a vast amount of training images. So basically, we have talked about the OCR solutions in Aurora Vision right now. Of course, I cannot really tell exactly how it's been trained, except for the general things like that we had used a lot of images. So let's maybe right now talk about two things. Deep learning can also provide us with masks. So let me just start. Okay, no, I think, yeah, it's not in this version yet. I'm sorry. Even the mask would basically show you what the model is trying to process. So if we had the dot print, the mask would not have separate dots. It would be joined, so that we could see what the deep learning model is classifying as that letter. And I just wanted to, at the end, I wanted to return to this matter of spaces and single lines. We can actually, if we set, as I did in the beginning, if we set the gap low, we have the array of strings, but it's not really ordered correctly. If we turn the indices on, 0, 1, 2, 5, 4, 3. So it's ordered correctly when it's ordered basically in one direction, which is from the top to bottom. So 0, 1, 2, 3, 4, 5, because this here is a bit higher than this point. So of course, we can use some methods, other methods to sort this text. For example, one of those methods would be just to, if we know how many lines we have, we can use an array of regions of interest. So how can we do it? The easiest way would be to right-click this and extract a step macro filter. So basically a function, a custom function. And now we can connect the region of interest to, so we can connect it as a parameter of this function. But what we want here is an array. Of course, it will complain about the issues because now we will read characters as many times as we have provided rows. So we need to change the type of this to another. We need to add another array. And now, using this alignment, we can do something like this. Have an array of rectangles. I'll just do the top ones. And when I run this now, let me remove everything so that we can see. Now we have it ordered correctly because we are not reading the whole paragraph, but only one line at the time. So we have client, Mr. Harry, street one. Yeah, I made a mistake because we need another step of order of sorting. And we can, in this case, we could, for example, sort it left to right. So we can add, with the control space, we can add sort array. We can connect the strings. And from the lines, we want the origin, which is the top left point. And when we connect, we want just one string here. And we connect the origin X. And we can now have the sorted array. And now this is correctly sorted in the horizontal direction. So yeah, if I move this here, the text is still correctly read. So basically, that would be all that I wanted to talk about during today's webinar. So now will be time for questions. So maybe I will temporarily let Stacy handle this. So if you have any questions, ask them now, please.
Thank you very much. Yeah, hello everyone. I'm going to be taking Stacey's place for these questions. My name is James Swinton-Bland. So thank you very much for a great session there. That was the first time I've ever seen a bit of hands-on with OCR from a machine learning and adaptive or Aurora vision perspective, I should say. So we've got a few questions here, 5 or 6 so far. Please feel free to add your questions to the question box on the sidebar, and we will get through to those in just a moment. So the first question we have here from Robert, can I use a Tc21 camera? So Tc21 is one of our enterprise mobile devices.
I am not yet familiar at the moment with this camera. I don't know, I just don't know the model of the camera, but basically when I go here, we have 2 rows of image acquisition in Aurora Vision. We have the generic GigaVision and GeniCam. So if your camera supports one of those protocols, we will be able to use this camera. And we also have third party. So this is something that we had to, well, add separately, because some cameras do not follow those protocols. We can see a selection of those. If your camera is not in the third party list and does not support it, then we would have to add support for this. Or you can also, provided you know how to program, you can also add support for this, because Aurora Vision allows you to create your own user filters. So I'm sorry, I cannot exactly answer your question, but I am not sure what that camera is.
No problem. I think you gave enough info there to at least point us in the right direction. So thank you. So next question here from Peter. Can we use the OCR algorithm for dot pin OCRs?
Yes, dot print. We can, but I don't have any images right now. I am sorry, but our deep learning model will work on dot print. I just did not think about having an example of that.
Do we have any examples on our website or documentation we could point Peter towards?
The examples, I am not sure if we no, because in our examples we don't have those.
Okay,
no,
no problem.
I'm sorry, but I cannot. But yeah, we had a lot of projects at Zebra Aurora Vision where we had to read dot print, so I can assure that the OCR model is capable of reading dot print.
Perfect, thank you. Peter, I guess if you get in touch with your sales rep or any contact you have within Zebra, we can get a little bit more info for you.
You can also contact us directly and we would provide you an example. It's you can I can give you the email, or I believe maybe it would be better to just send an email after the webinar with the information. Yeah,
no problem. Okay, so we've got quite a lot of questions come through, so we're going to have to try and get through these relatively quickly now. So
okay.
Based on the outstrings, it does not seem to include spaces. For instance, United States versus United States with a space in it. Can you elaborate on that? I believe you covered that already in the presentation. Is that correct?
Yeah, because we have the read characters only gives us raw characters, and the merge characters into lines is handling the extraction of words, and this extraction is based on the gap. If we set maximum gap very high, then basically every space between letters will be treated as non-space, so it will be done as one single word. If we set gap to a smaller, like here to 0.2, we had the lines separated into words. Like we can see that the lines are separated. The only problem is that we will still have to make sure that they are ordered from left to right or right to left, depending on the language.
Okay, perfect, thank you. So Paul Herford is asking here, do you get a confidence value of the decode?
We have the characters. I can note it here, for example. The characters have the score value, but usually when something is being read, it has a very high score. There were few cases where I saw, for example, a character with score of 0.7. But yeah, basically this is the confidence value.
Okay, perfect, thank you. Does the, sorry, excuse me. So this question from Joel, does the orientation of the label matter? What if the label is sideways or upside down?
Yes, I assume you mean the because when specifying the region of interest, we need to make sure that the orientation is correct. If I were to move it the other way, it will not really work well, because 70 up rotated by 180 degrees looks like L. So the orientation of region of interest is important, and we can see that this part of the rectangle, the label, basically, it will always be at the top left of the rectangle. So when I go back here to the proper rotation, the flags are now at the top left. So yeah, we need to specify the orientation, of course, with some tolerance. It doesn't have to be perfectly horizontal, but after some point, the letters are very deformed.
Okay, good to know. Thank you. So Kelvin here has a question. He also mentions that it's a very informative session and says thank you. His question is, can we read from shiny surfaces like metal or coins?
Yes, we had cases like that. Of course, shiny or not, we still have to have the letter visible, because as you could see here, right? Let me, oh, yeah. So this one is basically not visible in the image. So if there is some contrast, we will be probably able to read it. So it doesn't matter that the characters goes from bright on dark to dark on bright. It should be able to handle that. But usually it's best to focus on proper lighting setup so that the reflections are minimized.
Okay, that makes total sense. Thank you. Will an Aurora Vision setup be available for data wedge OCR? I have a feeling that might be slightly out of your remit.
Will be available for what? Could you repeat?
For data wedge OCR. So data wedge is an application we have on our mobile devices that enables scanning with the barcode scanner. So I think the question is, will data wedge support Aurora Vision OCR in the future?
I cannot really tell what is planned for the future, because I'm not at that level in the company structure. But at the time, deep learning, every deep learning tool, and we have a lot of them here, works only on Windows. We are close to officially releasing a version for Linux systems, but at the time, right now, we are only supporting fully Windows devices.
Okay, that's a reasonable answer. Thank you very much. Can we detect bad printing? For example, can we detect blurred characters printed on a label and alert the user to reprint that bad label?
This is not really in the scope of this tool, because what you're talking about here is OCV, optical character verification. And for that, we need to make sure what the font already is, so that we can compare it with the pattern, basically. And this tool, since it is trained on so many fonts, cannot really judge how accurate the character is. Of course, save for the score value, which might not really give you the information you are seeking.
Okay, perfect. Thank you. So from Peter here, is it possible to read dots, commas, and other characters like these? I have seen them in the accepted characters in the setting on the left-hand side.
Yes, so actually I just make it a bit less complicated so that it runs faster. So if I set this Greek, for example, right? So we have a comma here, because, and right here, and we have, excuse me, the characters 45. Yeah, so now the comma is ignored because it's not provided here, because the comma is a separator, so we need to escape this. So backslash comma, and now it's being read. Of course, we are also limited here to the Latin alphabet, numbers, and some interpunctions like slashes, hyphens, commas, and parentheses, and a bit more. So we may not be I don't, for example, know if we can detect the @ sign.
Okay.
It accepted it, so probably it cannot. Yeah, so there is some limited range of characters that it accepts, but the usual punctuation is available.
Okay, perfect. So we're at the top of the hour here, so I'm just going to try and squeeze in one last question, because we do have quite a few that are unanswered. So can we train and create a model in deep learning?
The OCR, as I mentioned before, there is no possibility yet for the customer to create their own OCR model. We can do it internally if the client or the customer requests it and provides an ample number of training images. But all the other deep learning tools in Aurora Vision can and even have to be trained by the user on their images. But the deep learning OCR is the exception to that rule. It cannot be trained yet.
Okay, perfect. So that is us at the top of the hour there. Unfortunately, we've run out of time. I appreciate there's lots of questions that we didn't have time to get through. So Emmanuel, Eric, Yona, Sherpa, Robert, and so on. I'm sure I'm missing a few names there. We have got your questions. I will make sure they get forwarded on and we get an answer back to you in due course. So with that, thank you very much, everyone, for your time and attendance today. I hope it was beneficial to you. I hope you gained something from this. We look forward to seeing you on our next Dev Talk next month, where we talk about Visibility IQ. I hope you all enjoy the rest of your day or your evening, depending on where you're based. Thanks once again to our great presenter as well, and we will see you all on the next one. So thanks, everyone.
And I want you to thank you for joining us here today.
Excellent. Thank you very much. Goodbye, everyone.
Goodbye.